paint on both sides of it a narrow strip line and spin the coin in the air, and when it falls, the direction that it's headed in is a direction that maybe you have the directions numbered 1 to 36, uniformly spaced. There are different ways to create random numbers, but the key thing is to remember that they have to be uniformly distributed over the length of the yardstick. Okay? Now, some students might say, well, gee, isn't this a continuous problem in the sense that x1 can take on any value between 0 and 36 or between 0 and 1 yards. It doesn't have to take an integer value, and that's true. So if the students are disturbed by the fact that we only put 36 numbers into this box here, you can say, well, let's make it more accurate. So we'll start with 1/4 inch, 1/2 an inch, 3/4, 1 inch, 1/4, 1 1/2, etc. So they could put, 4 times as many numbers in there. For demonstration purposes, this treating this as an integer problem is fine. And the way we solve it on the blackboard, we solve it exactly as it's a continuous problem. So, but some advanced students may ask about the integer approximation. Say, well, that's an approximation. This happens in engineering and science all the time. If you want to make it more accurate, put in more numbers and divide the 0 to 36 inches into smaller segments. Okay? So that's fine there. That's about all I'm going to say about segment number 1, which is just basically to engage the students and have some interactivity with the class. Okay, segment number 2 is basically a fun segment. The idea is to get the students to express to themselves and to you and to their classmates their intuition. Is it likely to form a triangle 80% of the time, 60% of the time, 100% of the time? And to get them to commit to it by putting their name, you can put their name on the blackboard and next to their estimate. Okay? So usually when I do this at MIT, I get 6 or 7 names, put 6 or 7 estimates. And the estimates typically vary from 100%, maybe down to 50 or 40%. Rarely do I get anyone who estimates as low as the correct answer is, which is 25%. But that's a fun thing. And usually by the end of segment 2, the students are really committed, really invested, and really want to solve this problem. They're really engaged in it. Okay, for pause number 3, the idea is that they need to find the event. They need to think about what conditions do we need to have solved so that a triangle can be formed with the 3 pieces. And so we have to formalize an intuition. And this is going back to fundamentals. So they think of the intuition. They now realize that sometimes we can form a triangle and sometimes we can't. We can't if one of the pieces is too long, and it can't just be the centerpiece, or it can't be the leftmost piece or the rightmost piece. Any one of the 3 pieces, each of them has to be not too long. And then the idea is, how do you crystallize, how do you formalize mathematically not too long? And then they think about it, and all of a sudden, usually there's an aha moment. Not too long means a half a yard. If each of the 3 pieces is less than a half a yard, boom, we can make a triangle. It may not be a pretty triangle, but we can make a triangle because the other 2, the smaller ones, will sum to a greater length than the longest one, and we can form a triangle. So that's the idea, is to get them very much involved with that. Maybe they haven't formalized it yet the way we do on the video following that segment. Some of them may go so advanced and so far that they actually cover what I cover in that next video segment. And that's fine too. Maybe they can solve the problem right there. That's great. All right? Okay, in pause number 4, the last pause, is basically I've shown the lower triangle in the square of outcomes, x1, x2. And that's for the case when x1 is greater than x2. Okay, so we have this lower triangle here. And what I'm asking you to do in class is to have the students figure out this upper triangle here. And they can either do it by going through the same 3 steps that I did here. This is the surefire way of doing it. Identify the length of piece 1, identify the length of piece 2 and piece 3. And then you can construct this the same way I constructed the first one. Or they can invoke a very powerful idea from mathematics, and that is symmetry. And if they invoke the symmetry argument, they can almost draw this by inspection. Okay? So that's basically the summary, and you'll see that I've given these notes also in the teacher's guide that accompanies this interactive video. And if you really want to see this whole thing worked out in animation, in color animation, on the World Wide Web, let me point to the fact that there's a URL, which is right here. It's a long one. I don't expect you to memorize this here, but this URL will also be in your teacher's guide. And so those of you who want to see basically a spaceship come in from outer space with laser beams and break a stick at random points and then solve this in color animation mode, that's available on the web. So thank you for trying this module. There's a website that you can make comments or send me an email directly at rclarson@mit.edu. And we look forward to your comments and constructive feedback. Thank you very much.